start. Can everyone please put their mics on mute, please? I hear some background noise.
Okay, your group is ready now? Yeah, you can start.
Hey, good morning, everyone, and thank you for attending our senior project final presentation. The presentation covers planning and design of the civil engineering systems for subdivision of ChillVille. So I present to you the A team. We're from different backgrounds and we work together very hard to produce the best work. My name is Lumia Eager. I am the Chief of Operations and I'm also a member of the structural team. My colleagues will have an opportunity to introduce themselves during their segments. One of our first assignments was to research, understand, and present on a project or article based on civil engineering systems. As you can see, our team's interests were varied and very diverse in different subdisciplines. Our second assignment was to produce a technical report in support of getting a permit from the local regulatory agency, Fairfax County in our case. So the proposed study area was approximately 1/4 of an acre, and the project was to demolish a 1,500 square foot home and build a 3,000 square foot home in its place. The report contained the following: all necessary permitting, erosion and sediment control plan, drainage plan for the site, stormwater management plan, and we needed to consider lead in our design. So of course, we first needed to research and come up with all the demolition plan permitting and all the new construction documents and permitting documents as well. And we needed to research our site as well. So the report was based on regulation from R3 zoning district from Fairfax County and in state of Virginia, which is what the plat is zoned for. We figured out the location in the watershed, or the project location within the watershed. And then we first prepared the drawing, which demonstrated the size of different surfaces in order to calculate the pre-runoff. And similarly, we prepare the drawing showing square footage after renovation to determine post. And then we calculate the present and future runoff conditions following 3 hydrologic methods: rational, NRCS, and TR55. All of this will be discussed in more detail at a larger scale in our next project. We also prepared an erosion and sediment control plan and provided options such as land grading, silt fence, inlet protection, tree protection, etc. And this is a drawing of our final conservation plan that shows the limit of disturbance and silt fence and the location of the site. And then finally, we recommended adding a rain garden and 5 rain barrels to control 0.23 inches of runoff. And for the second half of our school year, we were tasked to develop a large site. And our client's needs were given as such, as follow: to develop 50 acres in Prince George's County, to include mixed land use, townhomes, single-family apartments, businesses, to design all aspects of geotechnical, wastewater, water supply, traffic, etc. The client needed cost estimate, financial study, and the structural design of a multi-story building to serve as an office building. And so first we needed to consider our design constraints. The land contour, the slope and elevation, soil properties, perviousness of the soil, which can affect the delta of pre and post development runoff, traffic access management. We need to consider spatial constraints such as the roads, zoning restrictions, and of course the wetlands in the middle of our subdivision. And then we had to design a scope that fulfills our clients' needs, and that means optimizing the layout while incorporating local zoning ordinances, designing multiple systems of transportation, sewer, storm, and water supply, and performing a financial study and cost estimate, designing the multi-story building, a foundation and a fire protection system for that building, and managing the scheduling and project. So our subdivision is ChillVille. It's a place where residents can live, work, and play. But first, we consider zoning. So PG County Board is the approving entity of permitting. So the following has to be submitted for approval: general layout, a location, the topography of the site, the right-of-way and access to utilities, proposed layout of roads, streets, parking areas, etc., a sanitary sewer plan, and provisions for stormwater management. And we use the Code of Ordinances of Prince George's County and the Maryland National Capital Park and Planning Commission. The zoning ordinance has a cluster provision which divides the development into several shapes within the same zone. And this promotes variety and flexibility for residential communities while preserving the character of the neighborhood. So as you can see on your screen, there are 4 quadrants of 4 clusters of commercial apartments, park wetlands, and single family homes in the section and easternmost section of townhomes. Our team has produced several layouts alternatives before narrowing it down to the best 2 options shown on your screen. And finally, after further fine-tuning and calibration, we produced a final layout, and ChillVille was born, with 80 apartments, 26 family homes, 79 townhomes, office building, a grocery store, a pharmacy, a gym, 3 retail spaces, parking garage, and much more detailed in our final report. And now I will hand it over to my colleague, Marcel, who will discuss the next section.
Thank you, Lubna. Good morning. My name is Marcel Gauma, and I'm going to present the structural design of the multi-story office building. The criteria were to design a 5-story building composed of steel frame, concrete slab, and foundation. The objectives were to come up with layout, minimum design loads using ASCE 710. The structural analysis and load transfer were conducted using AISC Steel Manual and ACI 318. Next slide, please. Those are the main layouts of our design. The first one being the roof, and the second one being the foundation. Those were drawn on AutoCAD. Next slide, please. The code and regulation. The main codes and regulation that we used were the ASCE standard for minimum design loads for building and other structures, the International Building Codes, and the ACI 318. Next slide, please. The LRFD load combination were used to find or factored loads, which are a very important part of the design. So what you do is, once you come up with the different alternatives, you pick the highest one for your calculation. Next slide, please. The load transfer. Once you get the factored loads from the LRFD load combination, then those factor loads will be applied on the slab, will then be applied on the beams, then to the girders, then to the columns, and finally to the foundation. Next slide, please. For the one-way slab design, we determined the factored loads, then the maximum moment, then went ahead and did the beam design, then the main reinforcement, and finally the shrinkage and temperature. As you can see, our design, we found a number 4 steel at 12 inches on center for the main reinforcement, and number 3 steel at 10 inches on center for the temperature and shrinkage in the case of the roof. And for the floor, we found number 4 steel at 10 inches on center for the main reinforcement, and number 3 steel at 7.5 inches on center for temperature and shrinkage. Next slide, please. For the beam and girder design, we determined the tributary area, the factored loads, the maximum moment. We selected the beam using AISC AISC steel manual. Then once we selected the beam, we then redesign taking into account the beam weight. Next slide, please. For the column design, we determine the factored load, the slenderness ratio, and then finally we selected the column using the steel manual. Now, my colleague Natalie will be presenting the foundation design.
Thank you, Marcel. Good morning, staff, faculty. My name is Natalie. I am the lead geotechnical engineer, and my team was in charge of the foundation design. Our design objective consisted of receiving the boring log, which we used to analyze the soil report, and we also determined the structural report to be able to design the best alternative foundation. And this was necessary for the multi-level structure located in the commercial sector of ChillVille. Next slide, please. So our scope of work consisted of accessing the boring log data, which we used to analyze the soil parameters. We also accessed the column loads from the structural report. And depending on this, we designed a spread footing proposal for the foundation and also a design of a pile foundation. Depending on the safety, economic, and more functional factors, we chose the best design for this proposal. Next slide, please. So this is an example of our boring log data that we received. So upon investigating, we decided that the water table was located at 9 feet depth, and we determined that a shallow foundation would be best above the water table. A deep foundation we would find at about 45 feet depth. Next, please. So we consolidated our boring log data into our Excel template. From this, we put our soil parameters, our moisture content, N60 values, which we calculated. We also use this to determine our friction angle. Next, please. So depending on those factors, we were asking ourselves, do we design a shallow foundation or a deep foundation? We understand that a deep foundation is usually more expensive depending on the excavation cost. And a shallow foundation is ideal, but only if there is firm enough soil to support the structure. Next, please. So this is a look at how we decided to go through with the spread footing. And we know that for a shallow foundation, the depth to base ratio should be less than 4. We also use the standard penetration test to obtain our N60 values and calculate the N values. We also determine our soil unit weight, the soil cohesion, and friction angle. Typically, we use a factor of safety of 3, but for this, we decided on a factor of safety of 4. Terzaki's bearing capacity equation was used to determine the soil bearing capacity. And depending on all of these factors, we decided on a design of 10 by 10 spread footings at a 3-foot depth. Next, please. Then we took a look at should we use a deep foundation. We decided on concrete piles, and we know that the depth to base length ratio should be above 4. To determine the point bearing capacity, we use Meyerhoff's method. To determine the frictional resistance, we use Broad's method, and we calculated the allowable pile capacity with Meyer's method and Broad's method. We analyzed the concrete piles needed per column depending on the interior, exterior, and corner columns. Ultimately, our design was 1 by 1 piles at a 45-foot depth. Next slide, please. So our team recommends that we use a 10 by 10 spread footings at a depth of 3 feet to support the columns in the structural building. And this would not only meet our safety factor, but it would also reduce the need for excavation and our economic costs. And thank you so much for listening. I'm going to pass it over now to Lubna, who will speak on the retaining wall.
Thank you, Natalie. This is Lubna again, and in the early stage of our design, we quickly identified a need for a retaining wall. To retain First Street, which is shown on your screen, First Street Road, which is at an elevation difference from the adjacent wetlands. A retaining wall is a structure designed to support and retain soil at a slope that it would not naturally keep to. So our scope was as follows. We identified the elevation difference between the road and wetlands. identify the design code and lay out a procedure. We analyze the soil to determine the soil properties from the geotechnical report and design the wall dimensions and the reinforcement. Our procedure, in our procedure, we first analyze the soil and determine soil properties such as the soil bearing capacity, Q allowable, and a coefficient of soil friction. And then we approximate proportions of cantilever retaining wall, stem, heel, toe, length, and thickness. We calculate values of coefficient of pressure, and then we do a stability check for sliding and overturning. We check the wall thickness for shear, and then we design a reinforcement for stem, heel, and toe. And so we use a lot of formulas for soil analysis, factor of safety, soil bearing capacity or bearing pressure, reinforcement, and temperature and shrinkage. Codes used were ACI 318, IBC, and the design criteria for retaining wall in Prince George's County, Maryland. So first we calculated phi or angle friction. And then we initiated, we started initial measurements of a stem height of 16, and we approximated the stem thickness of 2 feet, base thickness of 2, and a base length of approximately 12 feet to be revised later. We come up with a coefficient of active earth pressure, Ka, and we calculate overturning moment and stabilizing moment. We check for factor of safety against sliding and ensure that it meets our requirement. And we do the same for factor of safety against overturning. And now we're ready to do reinforcement. So for stem, we use that procedure described previously to find a reinforcement of number 8 bar at 8 inches. And for temperature and shrinkage, we use number 5 at 7 inches. For the heel reinforcement, we use number 8 at 10 inches. And temperature and shrinkage, we use number 5 bar at 7 inches. And similarly for the toe, use number 8 at 10 inches for reinforcement and number 5 at 7 inches. This is our design summary. So for a 386-foot long wall, we need 22,000 linear feet of number 5 bar, over 16,000 linear feet of number 8 bar, and 770 cubic yard of cast-in-place concrete. And now I'll hand it over to my colleague Amin, who will present the next section.
Thank you, Lubna. Hello, everyone. My name is Amin Fazul Rahman, and I will be presenting the stormwater management portion of our project. So what is stormwater management and why is it needed? Next slide, please. Stormwater management is a fundamental part of any development because without an approved stormwater management plan, you cannot get a permit to develop any land. And this is achieved by conveying the runoff safely and efficiently to a wet pond through the storm sewer system. Next slide, please. So why is stormwater management plan needed for permits? When a land is developed, we see a change in the natural patterns and rates of runoff. Construction of buildings, parking lots, and roadways, all these impermeable surfaces alters the volume and velocity of natural runoff. Decreased infiltration and increased runoff creates the need for a stormwater management plan. The next slide, please. The objectives were to conduct hydrologic analysis to determine the pre-development and post-development runoff volumes and flows, analyze potential stormwater management system alternatives, select the optimal stormwater management system to control excess runoff, and finally design a stormwater sewer system and also the associated infrastructure such as curb and gutter, manholes, inlets, etc. Next slide, please. All the analysis and designs were completed in accordance with the following codes and references: Stormwater Management Design Manual by Prince George's County, Maryland Stormwater Design Manual, Volumes 1 and 2, and Prince George County Bioretention Manual. Next slide, please. These were the results of our hydrologic analysis. In case of the NRCS method, the curve number changed from 61 to 81 due to the development, which increased the 10-year runoff from 1.55 inches to 3.25 inches. In case of the rational method, the runoff coefficient changed from 0.4 to 0.6, which increased the 10-year runoff flow rate from 100 CFS to 168 CFS. Next slide, please. For our project, we analyzed two different stormwater management alternatives, which were bioretention, as we can see on the left, and wetland, as we can see on the right. Next slide, please. For the bioretention system, we divided the site into 4 drainage areas and calculated the volumes in each area. Then in the second table, we calculated the surface areas and the depths needed for those volumes in each one of the areas. Next slide, please. In case of the wetland, the drawing on the right side shows the surface area of the wetland at different elevations, and the table calculates the storage capacity of it at different elevations. Next slide, please. The surface area needed for bioretention would cause us to get rid of a number of commercial as well as residential units. This would impact our initial estimate of the revenue, whereas wetland would be feasible and more profitable as it is already located in a convenient location to be used as a storage, and it also has enough capacity as well. It will provide control for both the quality and the quantity of runoff. Next slide, please. So this is the procedure of designing a storm sewer system. First of all, the overland flow time is calculated, which is based on slope and surface time. After computing overland flow time, a time of concentration is calculated. Then the time of concentration is used along with the rainfall return period and duration to determine the rainfall intensity from the IDF curve. Then the design discharge to each manhole is calculated using the rational method. Then Manning's equation is used to compute the diameter of each pipe. Once we have a computed diameter, the next commercially available pipe size is selected. And finally, the last step is to perform a velocity check in each pipe to ensure that it is within the specified range. Next slide, please. So our storm sewer system was designed by dividing the subdivision into 2 sections, the eastern half and the western half. Each section has a trunk sewer which carries the runoff to the wetland at 2 individual inlet points. This method has an advantage that the 2 sections function independently, and also the pipe diameters stay relatively smaller. Thank you very much. Now my colleague Marcel will be presenting the sanitary sewer system design.
Thank you, Amin. Hello again. The sanitary sewer system design is a very important part of any land development. Next slide, please. The sanitary sewer system design is engineered to serve the community safely. Wastewater is collected and conveyed from buildings to main trunk at the north of the subdivision. The sanitary sewer performs 2 main functions, the first one being to carry the peak sanitary discharge, and the second one, transport any suspended solids without deposition. Next slide, please. The analysis and design were conducted in conformity with the following references: the Washington Suburban Sanitary Commission Manual and the American Water Works Association. Next slide, please. The design for the sanitary sewer system was based on the following: compute the peak sewage flow, Q peak, compute the ultimate peak sewage flow for the design, calculate the pipe diameter using Manning formula, determine the full discharge capacity, compute the required slope from Manning's formula, and finally do a velocity check for the desired range. Next slide, please. Those are the formulas derived from Manning's equation that we used for design. Next slide, please. This is our computation for the entire subdivision. What we need to take into account, we made some assumptions such as the number of people in single family houses, townhouses, and apartment buildings, as well as the inflow that might take into consideration for the design of the pipes. Next slide, please. For the hydraulic design, what we took into consideration was the street slope, the diameter of the pipe, the full discharge. Then we had to do again the slope required for each section. Then what we ended up with, we found out that the diameter of the pipes were lower than the diameter recommended by the county. So we used the diameter recommended by the county to finish our design calculation. And at the end, we ended up with velocities that are in conformity with the requirement. Next slide, please. This is the pipe network. As you can see, the pipe network covers the entire subdivision. We have a total of 21 manholes all connected with each other to carry the discharge to the north of the site. Next slide, please. Now my colleague Malik will be presenting the water supply system.
Thank you so much, Marcel. Hello, everybody. I'm Malik Shingler, and I will be presenting the water supply system design for ChillVille.
Can you increase the volume? We can't hear you.
Can you hear me better now?
Yes, please.
All right, awesome. Next slide, please. To begin understanding the process it takes to develop a water supply system, we must first understand the clarifying questions that go hand in hand with the design. And these questions are, why do we need a water supply system? How does one plan and design a functioning water supply system? What are the necessary calculations required for a water supply system? And what will be the cost? Upon the end of the segment, the goal for the audience is to have a better understanding of these questions. Next is the scope of work. The scope of work related to the design of a water supply system is as follows. The design of a water supply system to determine the pipe sizes, calculate the current water demand, design for future water demand, design for a sufficient head loss, record all pressure inside the pipes, determine all flows inside the pipes, conduct the hydraulic analysis using the Hardy-Cross method. Next slide, please. The design objectives. Like the scope of work, there are specific design objectives necessary to follow to construct a water supply system, and they include the following. Meet the water supply requirements of ChillVille to meet the water demand, meet the pressure heads, meet the fire demand, incorporate sustainability, minimize any chance of failure, design a robust supply system, consider all factors that can impede the supply sustainability. Next slide, please. So, to successfully design a water supply system, the procedure on screen describes all the steps taken. There are about 13 steps, and they are as follows. To estimate the current water demand for all land uses, calculate the flow related to the demand for each land use, calculate the daily rate and the fire flow demand, and you use the larger value between those two. You begin your first iteration and estimate the amount of flow considered in each pipe. You determine the pipe diameters and related roughness coefficients. You measure the length of all pipes and use the calculated K value. You use the Hardy-Cross method to calculate the head loss at each pipe and ensure the required demand is met. You find the absolute value of ratio between head loss and flow in each pipe. Next slide. With head loss and the absolute value, calculate the delta value. This is referred to as the correction factor. Then you calculate the Q corrected by adding the delta value to the previous flow. Next, you keep calculating the Q corrected values into your head losses within 3 decimal places close to 0, and add the head loss between all possible paths of flow through the development. Once the pressure of the inflow node is specified, the subsequent pressure at each node is calculated, and finally you estimate the total cost of the water supply system. Next slide, please. So these charts and figures are the calculations used to formulate our entire water supply system. The system took 11 iterations to yield a low enough head loss that can actually be used by our pipes. The first iteration is represented by the slides that you've been looking at. So next slide, please. And the final iteration is here, where you can see the yellow values represent the flow throughout the development, After the 11th iteration, the flow has changed slightly from the original iteration, as you can see on the screen. Next slide, please. Naturally, the design behind a water supply system does not come with ease. A multitude of calculations, recordings, and parameters are necessary for engineers to follow to successfully produce a sustainable water supply system. With these considerations in mind, our team was successfully able to model the ideal water supply system to provide for ChillVille. And now I'd like to introduce my colleague, Idis. She will be presenting transportation engineering and design. Thank you so much.
Hi, my name is Edis and I will be presenting traffic and transportation section. Next slide, please. So as you know, we were given a 50-acre site where we implemented various land uses ranging from residential to commercial to public parks. And our task for this section was to design the traffic and transportation aspect for this new subdivision in PG County, Maryland. Next slide, please. So we had various objectives, and our first one was to design the roads for efficient flow of traffic, not only for the residents, but also for the visitors and commercial vehicles entering. The second one was to have optimal access to commercial facilities for our trucks. So we did implement the concept of access management to accomplish it. We wanted all related roads to be created to withstand and maintain an expected growth of traffic volumes. And lastly, we wanted to assign the proper signage to the roads and traffic signals to help drivers with oncoming traffic, pedestrians, and other entities that can be encountered while driving. Next slide, please. So these are our codes and specifications that we use. We use the ITE Trip Generation 10th edition, specifications and standards for roadways and bridges, Code of Ordinances for PG County, Mixed Use Development Trip Generation Study, MDOT Annual Average Daily Traffic Locator, which used data from ArcGIS, and Manual on Uniform Traffic Control Devices. Next slide, please. So the first step toward design procedure was to follow the travel demand model. And this basically helped us predict the volume of vehicles in the subdivision using present data from PG County. So we did trip generation, trip distribution, mode choice, and route assignment. Next slide, please. So the second step was to do traffic control. And this helped us figure out the number of lanes and proper traffic signals and signage throughout our site and intersections. So we did level of service, warrant 3 and warrant 4. And what we found through our results were that our level of service was A throughout our roads. So we actually accomplished one of our goals. And the third step was to do parking generation. And this actually helped us figure out the amount of parking spaces that we have at the moment compared to what will be in demand. And we found that we have about 300 parking spaces for surplus, which is great because ChillVille will be possibly hosting events in the site. And the last one was to do mass transit. And this was just to basically figure out where the best location to put a bus stop in the subdivision. So we have one located outside of the commercial area, outside of the apartment, and one in between the townhomes. Next slide, please. So these are our cross sections. We have a divided industrial road, primary / principal secondary residential street. And what you will notice throughout our site is that we have implemented bike lanes throughout. And this is just to give our residents and visitors an option of biking on the roads. Next slide, please. So we have a tertiary residential street, and this is mainly for our townhome and single family home areas. Next slide, please. And these are the last two, the urban divided arterial road and urban arterial road. And these are mainly for our major streets. Next slide, please. So here is the traffic and transportation site layout. Following our design procedure, this is the layout of ChillVille with the designed roads, traffic signals, signage, and bus stop locations. And that's it for traffic and transportation. Now I'll be passing it on to my colleague Scarlett, who will be talking about sustainability and construction project management. Thank you.
Thank you so much, Edis. Hello, everyone. Good morning. My name is Scarlett Vasquez, and today I'll be presenting to you about sustainability and construction management at ChillVille. Next slide, please. The purpose of this chapter was to preserve natural resources while meeting our demands in infrastructure without compromising the ability of future generations. We will do this by following the LEED certification system guidelines displayed on the left. Next slide, please. For our sanitary sewer system and stormwater system, we decided on anaerobic digestion. This will produce energy we will use as fertilizer to preserve the natural environment. And bioretention plants and bioretention swales. This will address risks associated with pipes and preserve our ecosystem. Next slide, please. For transportation, we prioritize changing our material to recycled asphalt and concrete and enhance these by using porous asphalt and concrete to allow water to flow through them. Next slide, please. Our office building was designed to withstand the load of a green roof. This optimizes our stormwater management by controlling runoff and retention. Green roofs control 80% rainfall versus 24% for standard roofs. Another benefit is urban heat island effect displayed on the graph to the left. Please. In our commercial parking lot area, we have designated a floor for electric vehicles with charging stations. These emit less greenhouse gases and improve the air quality in our area. Next slide, please. ChillVille is excited about connected autonomous vehicles, CAVs technology. We are an electrical vehicle friendly subdivision and are moving forward with 5G technology that could make these a reality. Next slide, please. In conclusion, sustainability is the future. ChillVille is designed to be a community of sustainability and eco-friendly environment. Next slide, please. Now we will speak to you about construction management. Next slide. The purpose of construction management is to develop a plan and monitor the progress of our project to ensure correct methods are in place and these are completed in an effective time while staying above profits. Next slide, please. We begin with our project charter. This document authorizes the existence of our project and is a reference source for the future. It gives direction and sense of purpose to the team. Next slide. To monitor progress, we use Microsoft Excel and Microsoft Project to develop a Gantt chart that depicts the project schedule, tasks, team members, start dates, and due dates, making it easy for team members to visualize the plan over time and determine responsibilities. Next slide, please. This is also part of our Gantt chart. Next slide. For cost estimation, each team provided a material cost for their section. To these, construction costs were added, and our goal was to generate a return on investment above 1 for our project to be economically acceptable. Please. These are our residential housing costs for single-family homes, townhomes, and 2 apartment buildings, B1 and B2. As you can see, our return on investment for all of these were above 1, and our total revenue is $86,244,000. Next slide, please. These are our commercial zone costs, which also calculated return on investment above 1, and our total revenue was $24,551,000. Next, please. This table represents our estimated subdivision cost that totals $63,305,000. Next slide, please. In conclusion, the total cost of our subdivision came to $63,305,000. This is less than the total revenue of $110,795,000, making our return on investment above 1, placing our revenue above the 20% profit margin. Next slide, please. And this concludes our presentation. We want to acknowledge the University of the District of Columbia School of Engineering and Applied Sciences, the professors that guided us through this project, and our lab engineer, Mr. Pablo Sanchez. Thank you, guys. Next slide. Any questions?
Okay. Thank you, ChillVille Subdivision Group. And now question answer. I request the audience.
I have a comment, Pradeep.
Yes, sir. Okay. Dr. Jitinsi.
You guys, yes, you guys did such a good job, because I know I have been to several senior project presentations in George Mason and College Park, and I can assure you, you guys are one of the best. Very good job.
Thank you.
By the way, one quick question. Who picked that name? Funny name, I like that. ChillVille. That's Lubna's.
I think the initial idea was of Eries, but everyone loved it instantly. So
Very good job.
We're catering to Generation Z and millennials, so
Yes, we
that
can
was the
relate.
reasoning.
Very good job, guys.
Okay. We have a civil engineering board advisor, Mr. Dan Hanlon. Any comments or any questions, Dan, for the students?
Hi. I agree with Dr. Z. Very good presentation. I too participate in the capstone program and actually teach parts of it at University of Maryland. So I was impressed with your ability to pull everything together. You guys worked well as a team, which is always something I look for. So great job in distributing the responsibilities and then coming back together with a comprehensive design. Couple of quick questions or thoughts or comments on the storm sewer side of it. I didn't see anything related to climate change or the 100-year storm level applications. That is, as you probably are aware, is becoming a very, very major consideration for any subdivision development now. Do they have enough stormwater retention for the maximum storms? Because the maximum storms are becoming, quite frankly, normal storms in some cases, particularly along the coast. So that was one question. And then I did not see anything related to cistern development, what I would call development-wide cistern. Maybe each building might have a cistern that would help with its landscaping, but you've got green roofs, etc. There is an opportunity to capture stormwater, store it, and use it for your irrigation system. That also helps you with your sanitary, because you can submeter any additional water to that and deduct it from your water price, your water cost, because every drop of water you spend, you take from the system, take from the municipality and put on your landscaping, you pay a sewer fee for. So that is a very high cost to pay for, quote unquote, clean water to water plants when you have this ability to capture stormwater. So I would encourage you to look at cistern development, as well as the credits that you would get from WSSC and or DC Water, depending on where you are, for doing such things. In other words, they give you money to do these kinds of things and give you help buying sustainable equipment associated with it. So there are programs, grant programs associated with these organizations that can help your development. The water distribution system did not see anything related to fire protection. Fire protection is becoming, as you probably know, because of what's going on in California and other places, the fire code is changing, and in municipalities are now requiring, in some cases, booster pumps for fire protection systems. And you may have individual building booster pumps, but in some cases for subdivisions, they are requiring subdivision booster pumps, depending on the pressure, of course. That's to make sure that the hydrant pressures are adequate if and when they have problems with that. Again, just finally, I saw nothing with the traffic analysis that was good, that was a problematic for me. I thought you guys did a good job with that. On sustainability, lead guidelines are great for the community and the individual buildings. The anaerobic digestion management issue, I would question. You want to the extent possible, again, work with your municipality and make sure that you're sending the appropriate fluids to the municipality. I heard nothing about gray water systems. Gray water systems are something I'm getting involved with almost on every project now, where we're separating out certain components of the sanitary system to be reused either in irrigation, mixing with the cisterns, and or toilet flushing, etc. And I saw the EVs, which and the autonomous vehicle adaptation technologies, which I also thought was a really good approach. I did not see any alternative energy. I did not see deployments of PV in the parking lots or anything like that. And I would encourage you to look to that. Again, as you know, the Biden administration is pushing very hard on that currently. And there will be grants available to provide this type of alternative energy production that can lead to vehicle charging and vehicle charging as storage medium, again, battery storage in the vehicles themselves. There's programs being worked out for smart grid applications and microgrid applications where you can use the vehicles themselves as also storage mediums. So those are my quick comments, Pradeep.
Thank you, Dan. Now that you will respond.
Okay, thank you very much, Mr. Dan, for your comments. To answer your first question about the 100-year storm. So in our analysis, we did the 1-year, 10-year, and 100-year storm events. But since the code only requires us to design for a 10-year event and give storage capacity for it, we designed it for a 10-year. But we still went above 10-year by 13%. So whatever was the requirement for the minimum storage, our design provides 13% more than that. That answers, I hopefully answers the stormwater management part from me. And the question about the water supply for fire protection, we do not have any advanced fire protection system, but we do have, we do fulfill the minimum pressure requirement and the flow requirements for the relevant fire codes.
But you have taken the 1,000 liters, thousands gallons per minute, right? Whatever requirements we have already considered.
We are above. We're above the minimum requirements. Yes.
Okay. Next response.
Next response. As far as you said, I forgot your exact wording, but you said, per system, stormwater management, or per building. Mm-hmm. So what we did was, although our alternative was, the selected alternative was wetland, but we still do have a bioretention system in certain parts of the subdivision, just as an additional measure. Mm-hmm. It is well above the minimum requirements. The wetland alone fulfills the requirements, but we do still have a bioretention system. We have, as mentioned, a huge green roof in our office building, which can help with infiltration. And we also have a significant, I would say, percentage of pervious areas in our subdivision. Mm-hmm. Any other questions that I could?
Yeah, any like I see you see the comments and questions, that is excellent. What is required in the industry right now? So that's the reflection. And you guys try to find out this project itself involve all the elements or subdiscipline of the civil engineering, right? We have structural engineering, water resource engineering, transportation engineering, geotechnical engineering, construction project management, sustainability. So we try to find out, what the project selection so that you can cover most of the subdiscipline of civil engineering within, a few months of the academic work. Okay. I have questions for your group. What was the most challenging task in this project?
So as a group leader, I would say most of our challenges begin with the very beginning of the second semester, which is the large site development. Because the smaller site development, the teams were also smaller, it was easier to manage. We were 3 people in our team. But in large site development, once we started So I would say the main difference between our design courses and this course, I meant like the regular design courses, and the senior design course, the main difference was that although we are designing similar systems, but the parameters were not given to us in a clear manner. So all of us had practice from our classes about designing all these systems. But the challenging, or also the interesting part, was that we had to first set up our own parameters based on code and the guidelines given to us by our instructors, and then design our systems based on those parameters. So those parameters, such as zoning, topography, those were a bit challenging in the beginning. And one thing, of course, I would say is universal for all of us here, be that instructors or students. This pandemic situation has made communication a little difficult. As I think Carla mentioned, when you're trying to get something out of an instructor or even a fellow group member, you cannot just ask. So you're doing a calculation, you need help, you have to email them and then or text them and then wait for their response. It affects your flow, so you have to wait for their response, and then you have to go back and, oh, where was I, where did I get stuck, how did I get stuck? So that made it a bit more challenging to do some of the calculation work. But as the time proceeded, by March we were getting used to the online systems, and after that I don't think we had any difficult issues in the last month of the course. If any of my other team members have a point, please.
Yeah, may I add something to that? Thank you, Amin. I want to echo what Amin said, but I also want to add one of the challenging parts was that we were designing several systems that were intertwined. So one change in one system will impact all the other systems. So we had to work very closely with each other. This challenge we did not encounter in other projects and other classes, but this, because it was multidisciplinary, we needed to pay close attention to not only what we were doing, but also what other systems were developing as well.
Welcome to the world of engineering.
Yes. So, okay. And as with regards to teamwork, tell me what was the fun part of this project, working as a team?
I would like to answer that if I can. I guess that the fun part in working in a team was just to get to know each other at a deeper level. We got to know each other from not just interacting in classes, but how we work, how we function, our weaknesses and our strengths. And I feel like that was the fun part in working with each other's personalities. Our group actually became very close, and we got to know each other pretty well, and just interacting with each other. I think that was the fun part, and not letting anything really like opaque that in a way. Like, we were really good together, and when there was challenges, we were all there for each other. So I think just building that professional relationship was really fun.
Okay. So, okay. Any other questions from the audience for this group?
Can I add on to what Scarlett was saying?
Sure.
Yeah, like everyone has said, doing this during a pandemic has probably been one of the hardest things that we could possibly do, but our teams have made it so easy. I think at first it was really frustrating, and it was hard to figure out how to work together. But I think our professional skills kicked in, and we really learned how to communicate, and I think that's going to translate to the work field really well for us.
Okay. Any other questions? Sir, can you please, talk a little loudly, Dr. Girma? You have a question? Any other questions? I have some general comments. I will tell you that, if let's the question answer session for this group over. Yeah. Yes. You can take out these presentations right now. You don't have questions.
I'm sure. Yeah.
Yeah. So that we can see each other. Yes. Well, you successfully completed the presentation part of this projects, both the groups. Now you have to submit your original presentation and reports and drawing, all the submissions you have to take care. And on behalf of Civil Engineering Department, I congratulate you, each one of you. I'm proud actually to say this. I don't think in our nations, any civil engineering department produces 50% of women engineers. I'm proud of that. This is the first thing I'm proud of, that half of the class are women engineers. So definitely that's a milestone. On an average, we have 17% civil engineers, 16 or 17% range. We covered this batch, 10% women engineers.
We need to publicize that.
Yeah, so that's a good thing. And I'm really happy with this batch, as I always tell, that you meet we challenge you all the time, and you meet that challenge, and you have more than half of the students have the job offers before then they graduate. That is actually big progress in UDC civil engineering departments. Okay, now I'm really proud of that. And we want you to be successful, and all of you, I know some of you already passed FP exam, some of you are planning to appear in May, some of you are, so we see that everybody will be a professional engineer soon. Okay, so as you know, Ms. Dan Hallon is very much involved, Dr. Z is very much involved, and all in NSP. So we want you to be part of the ASC and NSP as soon as you jump into your professional career. So we are looking forward to all of you. We want to receive your FE and P, that letter that we will, we are looking forward to receive that.
We have several students, they will take, I believe, next week.
Yes, they're planning to take. So yeah, just, this is how we have planned our undergraduate students. Before they jump into the job, they will have a FE.
Unbelievable, really. I taught at George Mason, I told you before, like class of 45, zero passed the FE exam, first shot. Look at this class. I mean, how many so far? What? Amin and several, yes?
Yeah, Amin has passed already, and the rest are on the way to appear.
Carla and Kevin and hopefully Nuria and others, please.
Yeah. So
great job overall.
So another comment is, please complete your exit surveys. Whatever Dr. Hicks already given you, please complete the survey. And I would request all the audience to survey the forms that is in the chat here. In the chat, you can copy the chat, and it will be Google form. You can fill it up. I really appreciate that. And any comments from my colleagues to this batch 2021? You will be graduating soon in the few weeks.
I would like to thank all the professors, but specifically Dr. Behera and Dr. Z for the last 2 years. In my case, I'm a transfer student. So whatever you see today, if you like it, it's because of you. Even if you don't like it, if there are any shortcomings, that's also because of you. I would go both ways. And I would like to personally thank all 6 of my team members for putting up with me. I was at times, a bit too demanding, I would say, and a bit strict with my deadlines, but they did a phenomenal job, as all of you saw. Thank you.
Okay.
Now your job is to bring the PE certificates, young man.
Just give me a time, Dr. Z.
In 4 years. Yeah,
finished the presentation 10 minutes ago.
So as I said all the time, once you graduate, you are the ambassador of Department of Civil Engineering, right? You go and recruit one more in civil engineers or any other engineering to our school, to UDC, to make us proud. Okay, so you motivate. Our nation needs lots of, as you know, BLS requirements. Nation needs right now. Nation needs 35,000 civil engineers, right? So you need to encourage. A lot of my when I go to meetings, a lot of our senior professionals, they are saying that you recruit more engineering, civil engineering, because our nation needs it. Okay, our nation needs for rehabilitation of infrastructures, and Dan can say that how much need we need in the industry actually. So you are the ambassador for our program. So you need to recruit and, bring students to our department. Okay.
Great job.
Yeah. With that, I think we are on time to complete. Congratulations to each one of you. And I hope you have your exams. Now you have to submit your reports. Then looking forward to graduation and passing PE exam and moving on your professional career. I wish you all the best. That is on behalf of Civil Engineering Department.
Congratulations.
Thank you, everyone.
Thank you all.
Thank you, everyone.
Thank you, everyone.
Congrats, everyone.
Thank you.